My name is SP Tobela. I'm a lecturer at Ehlanzeni TVET College, based at Mashishini campus, under the program Engineering and Related Design. So today I'll be offering Engineering System, NQF Level 2. So we'll be looking at the topic Engineering System and their application. So before we go deep into the topic, I just want to explain what do we mean by engineering system. So we say engineering system are parts that come together to perform an operation or to do work. But then if you check on engineering system, we have variety of engineering system. We're still gonna look on each and every one. But then for today's lesson, we'll look at electrical engineering system. So firstly, we need to understand what do we mean by electrical engineering system. So we say an electrical engineering system is a system that uses electricity to transfer power. So if we say it uses electricity to transfer power, and then we have the basic component of which it makes up the electrical engineering system. So now we want to discuss the basic electrical concept. We have 5 basic electrical concepts, of which it's a conductor, an insulator, electric current, voltage, and a resistor. So now I want to check, or we are going to check or to discuss the function of each electrical concept. So firstly, as you can see from the picture, it's a cable of which we are all familiar with. So we say that we have the first electrical concept, it's a conductor, and we say conductor, it's a material or a material that allow an electric current to pass through them, e.g. we say copper. So if you can look from that picture, we have a wire, and that wire, it's copper, and you say it also conducts electricity, or it allows electricity to pass through. Then secondly, we're going to look at an insulator. We say that an insulator, or we mean that an insulator are materials that block the flow of electricity. For instance, you say we have a plastic. We know that a plastic doesn't allow an electricity to pass through. And we say we also have a wood. We all know that a wood doesn't allow an electricity to pass through. And as we can see from our picture again, we see that the wire, it is insulated. So that the insulation of wire, it's for our own good, of which we are not going to get electric shock. Then we're going to look at what do we mean by electric current. Remember, an electric current is also the concept of an electricity. So then we say an electric current is the amount of flow of electricity through a circuit. And therefore, we are having 2 methods of current flow used in a circuit. We have a direct current, of which we say it's a DC. We also have alternative current. So now I want us to discuss these 2 methods of current flow. First, I want us to focus on direct current, of which we say it's a DC. What do we mean by direct current? We say direct current is a current that flows in one direction in a circuit. If, for example, we say a current supplied by a torch, or the current supplied in a torch by a battery, of which we all know that a torch uses battery. So the current only flows in one direction, But then let us look at the alternative current. What do we mean, or what is an alternative current? We say that an alternative current is a current where the direction and amplitude of the current changes at regular intervals. And then we say, for example, an example of an alternative current we say it's a current supplied by a power station and supplied to houses. So we know that we use electricity each and every day. So you must know from now on that the electricity that is being supplied at home or in our houses, we say it's an alternative current. Therefore, let us look at the relationship between a current, voltage, and a resistor. Then we'll firstly focus on the voltage. What is a voltage? Or what do you mean by a voltage? We say a voltage is the force between 2 points that causes the current to flow. The force between 2 points that causes a current to flow. And then we look at the resistor. We say, what is a resistor? What do you mean by a resistor? And then a resistor is a component that opposes the flow of current. So remember, if there is current flow, or for example, if we can check in our house wiring, in our house wiring, we have bulbs. So bulbs are resistor because when the current is flowing, it resists. In other words, it draws the current. And then we are going to look at the relationship between current, voltage, and a resistor. So we say the relationship between a current, voltage, and a resistance is expressed by Ohm's law. Therefore, what is Ohm's law? Ohm's law states that the current flowing in a circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the current, provided the temperature remains the same. So if we say the current is directly proportional, we mean that the current is directly proportional. We say current is directly proportional to the voltage. This means that if the current increases, if the current increases, the voltage will also increase. But then, once again, it says the current also is inversely proportional to the resistance in the circuit. So that means if you say the current is inversely proportional, mean that it's inversely proportional to the resistance. This means that if the current increases, I want to write this down so that you will not forget it. If the current increases, or if the current will increase, therefore the resistance decreases. That is why we say it's inversely proportional. And in Ohm's law, it can also be mathematically expressed. By saying I is equals to V all over R. I is equals to V all over R, where we say our I is the symbol for electric current, and it's measured in amps. And we also say we have our V, of which is our voltage, also it's measured in volts. And lastly, we have our R, of which is symbol for a resistance, and it's measured in ohms. But then, remember, since we say this is a current, and V, we say it's a voltage, and R, we say it's our resistance. But remember, you can also make V the subject of the formula. Let's take in case we are being asked to calculate the voltage, then you have to make V the subject of the formula. So we can be able to manipulate this formula by saying, remember our original formula is I is equals to V all over R. Therefore, if you want to make V the subject of the formula, you simply cross multiply. Remember, we have an equal sign. You cross multiply, meaning your I, which is current, it's all over 1. Therefore, I times R. I times R, it's I, R, is equals to 1 times V. Therefore, we have our V. So then you can see that we are able to derive this formula and make V the subject of the formula in case we are being asked to calculate the voltage. And then once again, we can also arrange the formula by making the resistance the subject of the formula. Same applies if only we are being asked to calculate the resistance. So you need to understand how to derive the formula. It's very much important. So once again, we say we have I, of which is V, all over R. Therefore, if given I is equal to V over R, do the same thing. Remember, we are guided by this equal sign. Therefore, you say I times R. Therefore, it will be I R equals to V, of which is V for voltage. But remember, you are looking for R, or you want to make R the subject of the formula. Therefore, what do you do? Since it's I times R, it gives you the allowance to divide by I. But then you know that what you do on the left-hand side, you must also do on the right-hand side. Therefore, this I will cancel the I, and then we'll be left with R is equals to voltage all over I. Voltage all over I. So now we can see that we are able to make any the subject of the formula, any, it's possible. So now we are going to look at the types of circuit. We have 2 types of circuit, of which we have a series circuit. Therefore, what do we mean by a circuit? First, what do we mean by a circuit? We say a circuit is the flow of current in an enclosed area. Earlier on, we made an example of a circuit, and we say the wiring in our houses, it's a circuit. Remember, it's the flow of current in an enclosed area. Therefore, now we want to look at the series circuit. What do you mean by a series circuit? We say a series circuit is a circuit that only have one path through which current can flow. Only have one path through which current can flow. Therefore, as you can see from that diagram, you see we have our voltage from that diagram. Let me draw it here. We have our voltage. Remember, this is our power supply. So this is our voltage, of which is V. And then this is our resistance. Resistors. And then there is the flow of current. So if you say that it have only one path, so you can see we only have one path in which current can flow. Remember, it flows from positive to negative. So it flows from the positive path to the negative path. So then, we also have a parallel circuit, of which we say is a series circuit that have 2 or more paths through which current can flow. So if we say it have 2 or more paths, we mean that we have our power supply. We have our power supply. Therefore, we have our resistor. We have our resistor. I'm just making an example so that you can see what we're talking about. Therefore, we say, with this, remember we say this is a parallel. And the one that we discussed first, we say it's a series connection or a series circuit. Connection or a series circuit. Also have a parallel connection. So then if you can check from our diagram, we have two paths in which current flows. That is why we say it's a parallel circuit. So then this is given by, this is say it's our IT, and we also have our IT. So we must kindly note that in a series circuit, the current is the same in all resistors. The current is the same, which means that if you say it's the same in all resistors, if you have your IT, of which is your total current, is equals to, remember I said we have R1, R2, and R3. Means that the total current is equals to the current flowing in resistor 1 is the same as the current that is flowing in resistor 2, the same as the current that is flowing in resistor 3, depending on the number of resistors that we have. And therefore, it says the sum of an individual voltage is equal to the applied voltage. So we mean that this is our VT. If we are given a VT, of which is the total voltage, you say a VT, the individual is distributed across each and every resistor. So your VT will be equal to V1. Remember, it's distributed, which means here you're having, it will divide the voltage, will divide itself. And here from your R2, you also have another voltage. And on resistor 3, you'll also have voltage. But what is key is that the sum of the total voltage is equal to the sum of the individual voltage is equal to the total voltage. Therefore, again we say the total resistance is equal to the sum of the individual resistor. The total resistance of which is R1, R2, and R3 in this case. So you will say our total resistance of which is RT is the same as R1 plus R2 plus R3. So these are the formulas that we're going to use if we're calculating a series circuit. These are the formulas. And therefore, in a parallel circuit, we say you must also note that. Therefore, we're going to go back to our example. You must also note that the volume in the same is the same across each resistor. Meaning that if you say the voltage is across in each resistor, this is our VT, of which is the total voltage. The total voltage, of which is VT, is the same voltage that is distributed in R1. It's the same as V1. It's also the same as the resistor that is the voltage that is being distributed in R2, of which is V2. And we also say that the current of the sum of the current through each path is equal to the current flow. The sum of the currents through each path is equal to the current flow. So this is your IT. And then your IT means that it divides, the current divides itself along the circuit, since you say it's a parallel circuit. Remember, you say that the total current, it distributes itself in the two paths that we have in a parallel connection. So we say we have our I1 and also have our I2. So your IT is equal to the sum of the individual current distributed in each resistor. And we also say that the total resistor is less than the smallest of the individual resistor. So we prove this by looking at the formula. or of the formula that we use to calculate the R total, of which you say it's I over RT, T of which is R total, is equals to 1 over R1 plus 1 over R2. Since in this case we only have 2 resistors. But then if you're having more than 2 resistors, we're going to say R1, R2, R3, depending on the number of resistors that we are given. And then this, you can also use this formula to calculate the total resistance, of which it's RT. We say it's R1 times R2 all over R1 plus R2. But then you must note that this formula only applies if you are given 2 resistors. Once there are more than 2, then you're not going to use this one. You are forced to use the 1 over RT equals to 1 over R1, depending on the number of resistors that you are given. Now let us look at our first example. So example 1 says, in an electrical circuit, the voltage across a 1000 ohms and a resistor is 220. Then the 220 volts. Then the question says, calculate the current that flows through it. Calculate the current that flows through it. Remember, we say we're given I is our current equals to V all over R. So this is our formula. Then if you check from the given data, we are given R, of which is our resistance, as 1000 ohms. And also given V, of which is our voltage, as 220 volts. So now you're supposed to calculate or to determine the current. So then since now we have our formula, it's simple, we just substitute. We say, therefore, our I is equals to V all over R, where our V is 220 divided by 1000. So let's calculate, say 220 divided by 1000, and you'll get 0.22 amps. Remember, always remember to put the SI units. Always remember to put the SI units. Then let us look at example 2. Example 2 says that a 10 ohms and a 20 ohms resistors are connected in parallel across a 30 volt supply. And therefore 2.1 say draw the circuit. Remember, they say are connected in parallel. So then since they said they are connected in parallel, you simply say it's 2.1. You draw your power supply. This is your power supply, of which you have a positive and a negative, and they are given 2 resistors. 2 resistors, of which you can say this one is R1, this one is R2. So they say the first resistor are given as 10 ohms, and the second resistor 20 ohms, and our voltage were given as 30 volts. So this is how you're supposed to draw your circuit. But then remember, here we are having a current, of which we say it's IT. There's a flow of current. So we want to see the voltage of which they supply, we want to see the resistors, and we want to see the total current. And then 2.2 says calculate the total resistance. Calculate the total resistance. So since this is a parallel connection, you simply say your R parallel is equals to R1 times R2 all over R1 plus R2. Remember, we use this formula because we are given two resistors. So then now we say your R1, you say our R1 is 10. So we say 10. Your R2 is 20. And therefore, your R1 again, you say it 10 plus 20. Therefore, let's calculate. We say our 10 times 20 divided by 10 plus 20, and then we get 6,667 ohms. Remember to put the SI units every time. So it's 6,66 ohms. So now since we have the total current, we're going to calculate the total current. So 2.3 says total current, TIT. So our IT is given by our VT all over our RT. And then our VT, of which is the total voltage, we are given as 30 volts. And our RT, we have already calculated it from 2.2. So we'll just substitute 6,667. Therefore, 30 divided by 6,667, we are given it. Then you will get 4.5 amps. And then let us look at the last question. The last question says, calculate the current flow through each resistor. Remember, we have already said that this is a parallel circuit. So this is I total, and then it divides itself. The current divides itself, of which this one, it should be your I1, and we also have your I2. So now we want to know the current, or I1, or the current that flows in R1. So we'll say for 2.4, your I1 is equals to your V1 all over your R1. But then since you know that the voltage in a parallel circuit is the same, so you'll simply say your V1 is the same as your VT. So you'll say 30 divided by your R1 is 10, and 30 divided by 10 is 3 amps. And then now we'll look at the current that flows through I2 or through R2. So we'll say the current that flows through R2 or resistor 2, it's I2 is equal to V2 all over R2. So we'll say 30, since it's the same as the total voltage, all over 20. And 30 divided by 20 is 1.5. It's 1.5 amps. So if you can check, if you add if you add 3 amps plus 1.5, it will give you 4.5, of which is the total. So then you will know that your calculations are correct. So this will be the end of our lesson for today, of which I hope you enjoyed. And if you have any question or you have any comment, you are free to contact us on our website, of which is ehlanzenicollege.co.za. You can also follow us on our social media platforms, of which in Facebook we are Ehlanzeni TVET College, and also on Twitter it's @Ehlanzeni TVET, and you are also on YouTube @Ehlanzeni TVET College. Thank you.